Okay, so let's look at another new reaction. Just as a bit of review, earlier in this chapter you learned how to add one bromine to a carbon-carbon double bond, and you were actually adding a hydrogen to the other carbon of that carbon-carbon double bond. You also learned how to add two bromines to the carbon-carbon double bond. You've learned several ways of making alcohols from a carbon-carbon double bond. What we're going to do in this lesson is learn how to add two hydroxyls to a carbon-carbon double bond. And this is why the name of this reaction is a dihydroxylation reaction. So we're not going to look at the mechanism, but I still want you to know the reaction. The mechanism is a little bit complicated because it involves a transition metal. In this case, the transition metal is osmium. Osmium is down at the bottom of the periodic table in the transition metals section. Osmium tetroxide, which is what this compound is a very toxic compound. But you can carry out this reaction catalytically if you put in another compound called NMO, which stands for N-methylmorpholine N-oxide, which you don't need to know the structure of. You can look it up, it's in your textbook. But what this reaction does is it fairly readily forms this diol. So this is a dialcohol or a diol. You'll notice that I'm drawing it in a certain way. If you carry out this reaction with a cyclic alkene, so OSO4 and NMO, what happens is that the hydroxyl groups add syn. So this is a syn addition because they've added to the same side of the carbon-carbon double bond. Unfortunately, we don't have a good way of carrying out this reaction so that the OHs would add anti. We may see one later on. It just depends on how much time there is left in the term. So you do have to show stereochemistry of the addition. So for instance, if I take my alkene, now I have E2-butene and react with OSO4 and NMO, my OHs will add syn. And this is a chiral molecule, so there would be an enantiomer. If you start with the Z isomer, you will get, once again, the OH is adding syn. This time, though, there's a plane of symmetry, so it's not chiral. And in fact, I can redraw this by simply rotating around that carbon-carbon bond. And instead of drawing an eclipsed conformation, I can draw a staggered conformation. So this is eclipsed, and this is staggered. So this is a very, very versatile reaction. There's a lot of synthetic utility for having alcohols on adjacent carbons. Quite a number of naturally occurring compounds have this kind of a feature. One class in particular, there are many sugars have OHs on adjacent carbon-carbon bonds, and so it's a very useful reaction that you'll see quite a bit employed in the literature.